CO2 molding process and also defects in the casting. So these things will be discussed in today class. Okay, so let me start with the CO2 molding process. See, if fine silica sand is mixed with 3 to 5%, that is means silica sand having 3 to 5% of sodium silicate. Okay, silica sand and as well as sodium silicate is around 3 to 5%. These things you can able to mixed. Okay, see, this mixture is placed in the molding box and rammed. Okay, so the aggregate mixture, that is a silica sand and as well as sodium silicate, these two things will be mixed. Okay, so and then mixed sand is filled or placed in a molding box, and after filling, so then we can go for the ramming operation. Okay, then the CO2 gas, now after ramming, so the CO2 gas is allowed to at a pressure of 0.5 Newton per mm square for 10 to 30 seconds. Okay, so if you allow like pressure that thing, so automatically the molding box become dry. Okay, the chemical reaction taken place between CO2 and sodium silicate. Okay, so if the chemical reaction taking place, then it forms a formation of sodium carbonate and silica gel is result. Okay, so which gives the chemical reaction of CO2 and sodium silicate, then the result will get like sodium carbonate and silica gel will be formed. Okay, so the mold so the mold become harder and possess high strength. Okay, so if these results, then the mold become a harder and possess a high strength. Okay, the molten metal is poured immediately after gassing. Okay, so after allow the gas to the mold, so after allowing, immediately you can pour the molten metal, so here like this the process will be carried, that is called CO2 molding process. Okay, and then after completing of this, then what are the advantages of CO2 process? Okay, a few advantages are there compared to your say other casting processes. Say what are the advantages? Look at see here. Okay, see the process timely only a few seconds. Okay, so it takes a very few seconds to complete the molding process. Okay, can be used to produce a produce cores. Okay, it can be used for producing the cores for in order to do the cores operation, so we use this CO2 process. Okay, molds and cores can be used immediately. So here what are the things, if you do molding or coring, whatever the, so you can do immediately operation. Okay, so these molds are strong and absorbs resistance. Why? Because it become harder, and so this mold is a stronger one. Okay, so having a good absorption resistance. Okay, so it is suitable for mechanizations. Okay, these are a few advantages of CO2 process. And let us having same have a few disadvantages also having. So what are the disadvantages? Let me see here. Use of CO2 gas is expensive compared to other things only, so it may dry by using any other process. So here we use a special gas that is called CO2 gas. Okay, so that it is a costlier. Okay, compared to other process, it gives some expensive. Okay, so difficulty in reusing molding sand. Okay, so molding sand we are unable to use reusing. Okay, so it is having facing some difficulties. Okay, so and also it is a poor collapsibility. Why? Because the mold becomes stronger. Okay, so which has a poor collapsibility. Okay, so the cost of binder is high. The cost of binders are high. Okay, so as usually the CO2 we use. Okay, so that automatically the cost of binders is high. Okay, so having a few applications also there where it is used. What are the applications is there? See here the method is used for ferrous and non-ferrous castings. Okay, and suitable for thick wall steel casting and suitable for thick wall steel casting. So these are the applications. So this method is used for ferrous and non-ferrous castings and suitable for thick wall steel castings. So these are the some applications is there. So what are the defects? Then our next we will move on the next topic, that is defects in casting. So what are the defects of castings? Here a few defects after completing of your molding process and casting process. Okay, so after completing of your casting, you can send it for that inspection. So in the inspection area, we are able to find various defects. In general, after casting, what are the defects will be arranged to overcome the defects? What are the steps to be taken to prevent the the defects. Okay, so before that, so we'll see what are the defects will be erased in the castings. A few defects are there. So the first, namely, one is blowholes. Okay, so blowholes, and second one is a cold shut, and third one is a misrun. Okay, it's combined, it is cold shut and misruns. Okay, so it is two different. Okay, so and then next one is hot tears, and next one is mismatch. Okay, mismatch, and third one of fifth one is shrinkage cavities. Okay, shrinkage cavities, and next one is fins or flash. Okay, and next one is slag inclusions. So slag inclusions, and swells and scraps. These are the defects are erased in the castings. Okay, so there is a blowholes, cold shirts and mistrans, hot tears, mismatch, shrinkage cavities, fins or flash, slag inclusions, swells and swabs. Okay, these are the 10 around 10 defects are there. See, here we are able to see the figures how the defects will be. Erased, will see very clearly in the zoom. Say in the first figure we are able to find that is hot tears. Okay, in second also we will see the hot tears, and then next one is a porosity. Okay, then shrinkage cavity. I see how it is erased. Okay, and then blowholes. In general, the castings. Okay, the major defects is blowholes. Okay, and then next is scab. Okay, and next is swell. Okay, and cold shirt and misruns. Okay, so these are the 10 defects are there. Okay, so definitely after casting, definitely either of all these things, anyone should be erased. Okay, so the main thing is to prevent that defection by uh, doing some proper maintenance. Okay, so first we'll see, discuss the one by one what are the effects are there. The first one is blowholes. Okay, so these are spherical voids. Okay, blowholes means these are spherical voids, so appears on the surface. Okay, blowholes, and next one is so blowholes where these holes will be, whereas these are spherical voids. Okay, and appear on the surface, and next this will be occur due to why these blowholes will be arised. Okay, so why arised means due to poor venting. Okay, so venting means so by using vent rods we make the holes. Okay, so that holes is by using a vent rod we can make the holes on the surface of the mold. Okay, so why that holes are providing means, see, the hot gases are present in the molten metal. That molten metal contains hot gases. Okay, that hot gases are escapes from these vent holes. Okay, so that holes are not done properly, so we can made a poor venting, so that the blowholes is arised. One of the major area is arising the blowholes is poor venting. Okay, and next one is a lack of permeability. So permeability also one of the major defects will be arised by blowholes. So why? Because there is a blowhole. Permeability means the size of the sand. Okay, equal size. So next one is improper liming. So after pouring the sand into the mold box, you can made a proper liming. Okay, if you have not done the proper liming, so the gases are not coming out outside. Okay, so that what happens, so the gases are present inside itself, so that the these defects may caused. Okay, these defects may be erased. Okay, and the next one is more moisture content. If you are having the more moisture content also, so the blowholes may be erased. So these are the points while the blowholes occur after casting. Okay, so these things will be seen before doing the castings. Okay, so these are the points to be remembered before doing the castings to avoid the blowholes. And the next one is cold shirts and misruns. Okay, so cold shirt and misruns, these are the discontinuities in castings. Okay, these are discontinuities in castings. So these are due to poor fluidity of molten metal. These are due to poor fluidity of molten metal, improper filing and ramming. So improper melting of metals. Okay, so fluidity of molten metal. So here after pouring the molten metal, so the metal is there, the metal will be melted in the furnaces. Okay, so the melting will be done properly. Okay, so the completely it will becomes to a liquid form. Okay, they don't have any crystals which are present in the molten metal. So if it is there, so it will be avoid the fluidity. It means it cannot be flow easily flow. Okay, it will be stuck somewhere. Okay, so here the cold shed mainly arised due to poor fluidity, and that means the whatever the molten metal is there, that molten metal is poured in the mold cavity, so through sprue pin, so that the molten metal is immediately is entered into the uh, mold cavity, so it will not go properly, it doesn't flow, means so they're having flow, poor fluidity. Okay, so improper filing and ramming. So here if you are not done ramming properly, so same way blowholes will be arranged, and also closed sets will also arranged. Okay, so improper melting of metal, so that's what I told in earlier. So the melting should be done properly. Okay, so that is about the cold shed and mistrans. Okay, so cold shed means these are discontinuities in castings. Okay, and next one is a hot tear. So hot tear means these are cracks. Hot tear means these are cracks. So why the cracks will be arranged? So means occurs due to uh, contraction stresses after solidification. So due to the after solidification, the stresses will be developed. Okay, so the contraction stresses are raised. So automatically the hot tear means the cracks may be arranged. Okay, so due to improper castings. Okay, so improper castings also this hot tear may be raised. Okay, due to improper ramming. So the ramming is done very majorly, it plays a very vital role in the mold making. So the ramming done properly. If you are not done ramming properly, so the hot tear also may be raised. Okay, on the castings. Okay, that is about the hot tear. Hot tear means this cracks. And then next one is a mismatch. Why the mismatch is means a shift of individual parts of casting so occurs due to mismatch of scope and drag. So this scope and drag will be aligned on the axis. Okay, same axis. Okay, so it may having some deviation. So if you arrange the deviation, so the mismatch will be arranged. Okay, so due to improper clamping of flash. Okay, so the flash, that is scope box and as well as drag box, it should be clamped properly. Okay, so if you done improper, so automatically that mismatch will be arranged. Okay, a shift of individual parts of castings. So mismatch of scope and drag, and due to improper clamping of flasks, that is about the mismatch. And the next one is shrinkage. So so another important point is shrinkage. These are the voids in the castings. Okay, so shrinks means it will be uh, reduce the dimensions. Okay, see how why it is happened. So insufficient feeding. Okay, so the main thing is the pouring the molten metal in the mold cavity. So you can done a complete filling. Okay, so if you are not in feeding properly, so that will be shrink may be arranged. Okay, so shrinkage will be arranged, so occur due to poor casting design. Okay, so casting design is also poor. Okay, occurs due to incorrect arrangement of gates and risers. Occurs due to incorrect gates and risers. Okay, so occurs due to high temperature of molten metal. So here arranged molten metal, high molten metal. Okay, so here molten metal temperature is very high, so though also we can get the shrinkage allowances. Means it is a rapid cooling. If you take, automatically the casting will become strings. Okay, so that is about the shrinkage allowances. Okay, so that is shrinkage. And next one is fins or flash. Okay, so here we have fins and as well as flash. So it is a thin projection of metals. It appears along the mold joint. It occurs due to improper clamping. So that is about the fins or flash. It's a thin projection of metal. It appears along the mold joint. So it occurs due to improper clampings. That is fins or flags. Okay. Next is slag inclusions or slag holes. Okay, and these are cavities are filled with slag. These are cavities filled with slag. Okay, see, these are impurities of molten metal. These are impurities of molten metals called slag. Okay, due to poor skimming of molten metal in a ladle. Poor skimming of molten metal in a ladle is also due to incorrect gating. It's also due to incorrect gating. So that is the slag inclusion, or we can also call it as a slag holes. These are cavities filled with slag. These are impurities of molten metal called slag. Okay, so due to poor skimming of molten metal in a ladle, and also due to incorrect gatings. Also due to incorrect gating. And then next is swells. So here we have the two main factors. One is the strings, another is swells. Okay, so strings and other swells. Why the swells will be arranged? Okay, so the surface will be non-uniform or oversized. Okay, so if it is a oversized mold cavity, so that also we can get the swelling option. Okay, you see why it is occurred means it is due to improper ramming and rapid pouring of molten metal. So if it is a speed pouring of molten metal in the mold cavities, so that the swell may be arised. Okay, the factor of swell also arised. Okay, so that is the surface will be non-uniform or oversized. Okay, it occurs due to improper ramming and rapid pouring of molten metal. So it is opposite to this shrinkage. Okay. Next one is scabs. Okay, so these are lumps of excess metal. These are lumps of excess metal. So irregular projections containing sand enclosures. Okay, so scabs. So these are lumps of excess metal. Okay, so irregular projections are containing sand enclosures. Okay, sand enclosures, that is called scabs. So why these scabs are arranged means due to improper ramming. So these scabs are eliminated by proper ramming and using of fine facing sand and controlling flow of metal. So the flow should be controlled and it has a good fluidity. Okay, so it removes lumps of excess materials. Okay, so that is scabs is proper ramming. So the ramming plays a very major role in all defects. Okay, so that is about the scabs. Okay, so today we will discuss about the few points, that is the CO2 casting molding process, and also the defects of castings. Okay, after completing of the castings, so we send for the inspection. So in inspections we will find these at 10 types of defects. Okay, so before going to while preparing, so you are aware of all these defects. Okay, so if you are aware of all these things, then you can try to minimize the defects while in after casting. Okay, so that as few defects may be erased. So if you are aware of all these things. Okay, so I will go for the, so with this our foundry topics will be completed. Okay, so we'll meet again tomorrow with a new chapter. Okay, so thank you.